Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for this week's episode. You are stuck with just me this week, no guest. I am going to be talking about something that I know I've talked about before on the podcast, but I try to bring topics to the show that I see technicians and people in the automotive field struggle with on a regular basis, right? I utilize my mobile business, diagnostics, programming, and keys in order to kind of keep a finger on the pulse of what's going on out there in shops with technicians. And I may have a slightly biased perspective because a lot of the shops that I'm getting called into have more struggles than some of the top tier shops that are out there, right? If you're a top 10% as far as ability, skill level, tooling, resources in the automotive world, you're probably not calling me to come in outside of some strange circumstances where I'm programming some, used Volvo module or something where you just don't have the equipment, but if you did, you could figure it out, right? And this applies specifically to the diagnostic portion of things, is that I'm getting called into shops where, there are a lot of struggles that a lot of probably you listeners have overcome. But again, the vast majority of automotive shops out there do have some of the same struggles. And those are the kind of topics that I want to bring to the show to you, the listener, so if it is something that you or, some people in your shop are up against as well, I can provide some information, some insight, some resources to help you get through some of this stuff. So the whole point of the show is to provide good information to the automotive world to the best of my ability. So anyways, that was a long intro. I haven't even said what we're talking about today. What I want to discuss for a little while is how understanding how something works, whether it be a component or a system on a vehicle, is critical to diagnosing it with any amount of success. And that sounds very simple, and I know I've talked about it before, but I keep running into situations in shops where there is so little understanding of how a system or a component works. What does it actually do? How does it actually do it? What systems or components or wires or circuits are even involved? How does it work during a fault? What's necessary for it to work, right? All of these things that go into how does it work? A very simple statement, not always so simple to apply to everything in a vehicle. But without that knowledge, quite often what I run into is technicians or shops that can't even identify exactly what the problem is, let alone diagnose what specific component or circuit or system has failed. And let me give you an example of this. Had a shop recently, it was an old Pontiac Grand Prix, the 3.8. I think this was like a 2008 or something like that, one of the last years of Pontiac. But compared to today's, 2023 vehicles, a pretty basic, simple setup. Although during the 2008, in 2008, we were transferring more towards networks and things like that. Anyways, this thing would not crank. And of course, most people in this field have changed a starter, understand what a starter does. and can understand if the starter's not coming on or not, right? I mean, most people can figure that out. It is a no crank. And they're very fixated on the starter and the starter circuit, right? We've got a relay, and they did understand that the engine control module needed to ground or activate the relay in order to send power to the starter. But that's about as far as they got. And they did some testing and some messing around and really weren't able to come to a conclusion, where the issue with this one is that the ECM didn't communicate at all. And it turned out to be a broken power wire over the valve cover. It's very common on those and some of the Buick, like the LaCrosse, same model with a 3/8, the wiring harness would rub on the top of the valve cover, and it was a power wire that goes to the ECM or the PCM in that one. And if the module doesn't power up and in turn does not communicate, of course, it's not going to operate the starter, right? And I've seen this before in other situations too, where it is a network communication issue that's taking down modules, and a lot of time that being the engine control module, which in turn turns it into a no crank. But the technicians are just fixated on the starting circuit itself, whereas they didn't even identify that, hey, I can't talk to the PCM. I need to address that first and not even think about the starter until I can talk to the PCM, right? And there was no check engine light on the dash. That's a key to me on that particular vehicle, that the ECM's not online. My scan tool can't talk to it. There were codes in other modules saying they couldn't talk to it, right? And so I've been down this road many times, but I understand how this works, is that this module has to be awake. It has to be talking to not only me through the scan tool, but the other modules on the vehicle in order to do any of its functions, including the starter, right? So because I understand how the system works, and again, this is a very basic explanation, I can ignore things like the starter or the starter relay or anything like that. I don't even need to think about that until I can talk to my ECM, right? But that's because I understand how it works. And that's what my topic for today is how does this present itself in our industry, and how can we improve? How can you make this work better for you so that you're not up against this all the time? Or what do you do when you are up against something? How do we identify, I really don't understand how this works as much as I thought I did or at all. And what do I do at that point in order to understand it? The way I like to simplify this, or, try to explain to my students about understanding how a particular component or system in a vehicle works, is thinking about playing a card game, right? And there's a bazillion different card games that you can play. I like cribbage myself. I'm not terribly good at it, but I do enjoy playing cribbage. But imagine trying to play a card game like cribbage without understanding the rules of the game, right? You've never played it before, and you don't know the rules, but you're going to hop in the game and give it your best shot. Now, you understand cards, right? You've seen playing cards before. You understand the suits, and you understand the king, the queen, the jack, and all the numbers, and you get that. But you have no idea how those are going to correlate to the exact game that you're playing, right? You understand there's a starter, you understand that there's a relay, you understand that there's circuits, and maybe even that there's an ECM, but you don't really understand how these things are going to work together to make something happen, right? And so if you hop into this game and you don't understand the rules, that you're trying to get, pairs and 15s and how the board works and cribbage, you don't stand a chance. Even against somebody who's not even that good at the game, as long as they understand the rules, they have a massive advantage over you, and there's no way you can win. And it's the same thing when we start to try to tackle things in a vehicle, diagnosing problems specifically. If we don't understand how they work, at all, good luck. Just because you know the components involved, you're not going to be able to do a whole lot with that. Now, there are things that apply across the board, right? Like electricity. And we can take our knowledge of electricity and how that works and how it's always going to work, and we can apply that across the board. And that would be like understanding, what a 2 is or what an ace is, right? You understand the card, but you maybe don't understand exactly how it's utilized in the game that you're playing. And same thing with electricity, okay? You understand volts, amps, Ohm's law, all that stuff, great. But do you understand how that vehicle is applying electricity for an air-fuel ratio sensor, for a CAN bus network, for something you've never seen before, right? And that's the thing, is you really want to ask yourself, okay, I understand that there is this component. I understand that there is electricity involved. There is voltage on this wire, but what should it be? How is it applied in this specific application? And I like to ask myself as I'm going through a vehicle, trying to figure something out, and, just check myself to see, do I really understand what is supposed to be here? And it's usually easy to say, yeah, I don't understand this at all. I've never seen this before. But we can also run into scenarios where we think that we understand something, but maybe we don't understand it as well as we thought. Or maybe things have changed. A newer model year has a similar system, but they're doing something a little bit differently. And we can take some of our knowledge from previous models, but not all of it. Or it could be a completely different brand of vehicle. Brands can have the same types of system, like electronic throttle, but the strategies could be completely different. And so how it's going to react to a specific fault may differ from one brand to another. Or when we're actually doing the diagnosing and we get some sort of test value, that could take a different significance to us depending on how the system works. And one of the examples that I've used before on this is the resistance of a CAN bus network, right? We should have 60 ohms if we measure the resistance of the CAN bus network. If it's complete and the system's off, there's no activity on the system, 60 ohms, the two 120s in parallel make 60, right? Now, if I measure that on, let's say, a Chrysler vehicle, and I get my 60 ohms, that's good. That's what I want to see, but it does not mean as much to me as if I were to measure 60 ohms on a General Motors vehicle. And that is specifically due to the way that they construct their network, right? And so we can have the base knowledge of what the resistance is for a CAN network, but we need more knowledge to apply it to a specific system, right? Again, going back to the cards, you can understand what an ace is, but depending on the game that you're playing, that ace can take a much different significance to you, right? If you're playing Slippery Ace, which is a really fun game, if you've never played, look it up and play it with a large group of people at a party. It's pretty fun. And it's a very simple game too, but you do not want that ace, right? That's the whole point of the game, is to avoid ending up with the ace at the end of the round. So you got to get rid of that thing. Whereas if you're playing cribbage or poker or another game, that's not necessarily the case. You may or may want the ace. And there's other games where you really do want that ace, right? It takes on different value depending on where we are applying it, even though we understand the base concepts, right? So we're going to take these fundamental things that we know, but we've got to apply them to specific areas. And if we can't do that, and this is what I see a lot, technicians, is they know the basics, they know the components, they have an idea of what they do and kind of maybe how they interact, but they're not taking the time, or they just haven't taken the time yet to apply it to that vehicle, that circumstance, that grouping of components. How do these things work together on this car? And how do I figure out, and what does it mean when I get this test value? How do I apply that to figuring out the problem? That's what this is all about. And this is where the work comes in order to do these things. So I'll give you a few quick examples here of things I've run into recently where I've had to learn something new. And this happens to all of us, and myself included, that you're running into things that maybe you haven't seen before all the time. I would say even if you work at a dealership and you work on one line of car where you see the same vehicle over and over and over again, you're still seeing new vehicles every single year. And the systems are going to change, the strategies are going to change, the technology is going to improve or change. And you've got to learn something new. I know at the dealership they'll have ongoing training, and that definitely helps to understand the new systems, but sometimes you do have to take it into a real world application. And even the manufacturers can't always predict how these systems will react to certain faults. And so that's something a lot of times as a technician you're experiencing for the first time. But in the independent world where we're seeing all makes and models, it's too much for everybody just to know off the bat. You're going to run into something that you're not super familiar with. Again, we can take knowledge from other vehicles, but you're going to run into a specific system with a specific computer strategy maybe, or a way of operating, or components arranged in a specific order. You're going to have to take the time to understand how that one works and how these components apply to that system, how the electricity applies to this system in order to do some testing and come up with a conclusion, right? Some of the vehicles that I've run into recently that were top of mind, one of them was a F250, and this was an older vehicle. This is a 2008, so this is nothing new. And it had a 4x4 issue, right? It's winter right now. Everybody's using their four-wheel drive. The front hubs wouldn't engage. Now, these are vacuum-operated hubs, and as my time as a technician at Firestone, I dealt with Ford trucks and vacuum hubs a lot. But I dealt with the gas ones, which means F150 is with a gas motor that use manifold vacuum and a solenoid in the vacuum hubs, right? This F250 that had a diesel motor, although the idea is similar as to how these vacuum hubs work, and you could say the hubs themselves pretty much work the same, the control system is actually quite a bit different than the F150. And I had to stop. Once I got into it, I'm like, oh, I don't understand how this works. Like I thought I did, right? When the shop called me, I'm like, oh yeah, I know these things really well. I know exactly where the solenoid is. I know exactly how it works. I've done a ton of these. And then I look under the hood. I'm like, oh, hang on a second. This is different from what I remember. And I actually had to stop and read up on system operation to understand how this thing works. And it has a pump as opposed to using manifold vacuum. So it's a diesel. And it has a solenoid, but the solenoid, the way it's controlled, right, it still is just a solenoid and it's controlling vacuum. But the way that this solenoid's controlled is different than the F-150s. The strategy is a little bit different. And again, there's a pump that develops the vacuum, and this pump will shut off when the proper amount of vacuum is developed. Again, very different than what we're used to seeing, or what I should say with what I was used to seeing with the F-150s. So I had to read up on it in order to diagnose it properly. Had I gone about it just with my previous knowledge, I maybe could have come up with a solution, but not as quickly. And that's part of it, is identifying when you're in that position, like, oh, I don't understand this. I don't get how this works. And at that point, making the decision to stop and take time out of your day. And this is what is difficult, to read up on how that system works in order to diagnose it effectively. And I think that's where a lot of technicians maybe fall short, is that they're not willing to pause at that point and say, I got to go over the computer and read. Or even just, maybe watching a training or a YouTube video, whatever it is. We'll actually talk a little bit more about how you do this towards the end of the episode, but it's about pausing and taking that time in the moment. And the tough part, and I know this very, very well, now that I'm, out doing mobile every day, and I've got a busy schedule and I've got 4 other jobs to get to, and I'm trying to keep everything in, in good time for the day so I can get to all my jobs and everybody's happy. Oh, I got to spend a half hour to pause here and read up on this. In the moment, when you're hustling, when you got a ton of work to do, maybe there's some stress, maybe your boss is leaning on you to get that car out, maybe you're already way behind for the day. This can be really tough to do. To pause and stop what you're doing, and maybe it seems like it's inefficient, but in the long run, you're going to get to the conclusion quicker. And you're most likely, you might still, but you're most likely not going to make a bad call if you really do understand how the system works, you're able to figure out or find the information on how it works, then you can do some proper tests. Another one that I seem to run into a lot that I have to read up on constantly, because there's so many variations even within one brand, is anti-theft and starting systems, right? And so this involves the keys for the vehicle, and now that we have push button start systems, but even without push button start systems, where there's a transponder key and an anti-theft system, some of these systems are extremely complex. Toyota push button start systems come to mind. And that is one where I have probably spent hours and hours of my life reading up on how those systems work. And I still would not say I'm an expert on it. I still, if I get one right now today that I have to diagnose because it's not working, I wrote myself out a diagram, explaining it to myself like I'm 5, because that's what I need sometimes, on how these systems work, because they're, in my mind, pretty complex compared to some other systems out there, right? And again, when you get into it, okay, this thing doesn't key up, right? Where do I go? How do I even begin to diagnose this system? Something like that, one way or another. If you want to figure this out, you got to spend the time. You've got to invest the time to learn how this thing works. You got to seek out the information, consume it and understand it, and then you can apply it. If you don't, I mean, good luck. You're just going to be guessing at parts. And again, that's what I see a lot is, okay, I know the ID code box is involved. I know the smart ECU is involved. I know the steering lock modules involved. I know there's an ignition switch, and I know there's an ECM. I guess I'll just start putting parts on it until something happens, right? That's the approach of a lot of people, because then you can keep moving. Okay, yeah, why don't you order me an ID code box, and then I'm gonna get onto this next vehicle. And then it shows up in 2 days, program it in, still doesn't work. Okay, let's get a smart or certification ECU. Okay. You wait a couple more days, that doesn't fix it, right? Until you've replaced all the components and it still doesn't work. That's what happens a lot, because in that moment you're weighing the options, and your options are stop what I'm doing, take a longer amount of my day on this job, maybe miss out on some other work to try to figure out how this works. And then maybe I'm coming back and I'm doing some tests and I don't quite understand the results of the tests. So I've got to do more research on the actual circuit values. And hey, maybe I can't find any information on what's supposed to be on this circuit. And now I've just wasted a whole bunch of time and I still don't have an answer, right? Or do I just make my best educated guess, maybe the top hit on an Identifix, and then move on with my day and keep making money, right? And it's another, it's a rabbit hole, but, the argument can be made for the flat rate pay structure, encouraging that type of attitude, adding to that nudge to just keep moving. Okay, let's make our, best guess. And if you can get above a certain percentage of the time you're correct, most shops probably aren't even going to bother you about it. If you're right 70-80% of the time, the shops that I know, they'll probably leave you alone on it unless it's something extremely expensive. They'll just let you keep going as long as you're productive in other areas. But of course, what I do specifically, I got to try to be as accurate as possible. So this is where the other option of stopping and actually taking the time to figure out how this works is more valuable to me, because I'm charging a premium rate. I got to do my best to have an accurate answer. And even when I do that, sometimes I'm not right. But I try to make that as small as possible. And that's, again, what this whole thing is about here. So the question becomes, okay, so I've decided to stop what I'm doing because I don't fully understand what I'm involved with. I don't understand how this computer network operates together. How do these modules interact with each other? Who needs to be present? Who sends what information to who to make this vehicle power up? Or I don't understand the strategy for this computer when this fault is present. or when this piece of sensor information is skewed, how is this computer designed to, or how does it react to the information that it's getting? Yeah, I don't know. I don't have an answer for that. Okay, I've decided to stop what I'm doing and maybe lose some production for, this moment or today to try to gain that knowledge. Okay, now how do I do that? Now, in the moment, of course, your options are somewhat limited. And we'll talk about some ways that you can set yourself up for success even before you get to this point. But in the moment, most people are obviously going to say service information. And that is really, really important. Having access to good service information is going to get you your answer, I would say, the vast majority of the time. Not always, definitely not always. There's times where service information is lacking. But if you have access to good service information, which you should if you're doing this stuff for a living, you can find a large majority of what you need by taking the time to read. And I've had some other episodes where I've talked about, the specifics of getting into service information. One of the big things I always told the students was, if we're dealing with a computer issue and we've got some codes, make sure to go into the code information and read everything. Read the enable criteria. Read all of the conditions to set and to clear the code. Read through the flow chart. You don't have to follow it, but read through the flow chart so you understand what is this engineer that developed this trying to get me to look at with this flow chart? What circuits are involved? Maybe what are some of the values? Okay, they're having me ohm check these circuits. I don't want to do that, but okay, well, this circuit is involved. Why is that circuit important to this particular code, right? There's a lot of good information in there. And the description operation within service information, that stuff's gold a lot of the time. Again, there are some manufacturers, I'm thinking European a lot of the times, where that's not so great in the service information. They don't lay out a whole lot of stuff. A lot of the European stuff, it's included with the factory scan tool, right? So if you're using aftermarket service info, boy, there's next to nothing when it comes to looking at description operation. Now, you can access factory service information for a short-term subscription to most manufacturers. And you can use NASDIF to figure out the links, but you can also just do some Google searches, and you can buy a day or two of factory Ford information or factory GM information, Toyota, Honda, so on and so forth. And you can get it right from the source on what they have to offer. Now, I've done this before, and there are times where that doesn't get me my answer that I need. Sometimes I've done it and I found out, the stuff that was on AllData and Identifix is exactly the same as the factory information, and it's just lacking for what I want to know specifically. Okay. It's going to be the first place I look, though, and that's the first thing that I wanted to bring up was service information, which I'm sure most of you are aware of. But building an ability to search within service information is also really important. Navigating the systems that you have, I think that's key in order to finding what you need, right? And that's becoming true of a lot of things today, even outside of the automotive industry, is all the knowledge is out there. I'd say most of the knowledge is out there on the internet. A lot of the times it just comes down to your ability to search for it and find it. And that's true within service information too. So I would say if you're using a system on a regular basis, like Mitchell or MotoLogic or Identifix or AllData or whatever it is, really get to know it. If you don't understand it completely, take some time to really navigate it. Maybe there's that tab that you never clicked on because you didn't know what it meant. Well, click on it, see what happens. How does it help you navigate or not help you navigate within the service information? And the better you become at it, the quicker you can find these things. And I've talked about it on the show before, but the Control F feature just changed my life when I finally discovered, well, I didn't discover it, someone showed it to me, and I'm like, well, this is amazing. I can find all the times that Valvetronic is brought up within this PDF with a couple clicks rather than scanning every single page and reading everything, right? So there are tricks, there are shortcuts that'll help you get to the information that you're looking for. Now, beyond in the moment, right? How do we set ourselves up for success beforehand, right? You're still going to run up against a system you don't understand, and you still have to, make a decision in that point. But what else can we do outside of right there in the moment to make this better for ourselves? Obviously, one of the big things we can do is training. Okay. And there are many different options for this nowadays. There's in-person training like ASTE, like Vision, like Super Saturday. There's a number of other ones. I could go on and on. There's all kinds of training events that are in the U.S. particular. I don't know so much outside of the U.S. I know we have listeners outside of the U.S., but there's also online options, which are more popular than they've ever been after COVID. CTI does all kinds of online classes. John Thornton with Automotive Seminars just released his 23 schedule. There's all kinds of great classes that he's going to be putting on. And those are great because if you purchase it, you get the recording. You can watch it as many times as you want. And as much as I do love an in-person class, man, having that recording to go back and watch like a year later, that's been fantastic for me. And there's been times where I'm like, I know I was in a class about this. I'd really love to revisit that. Having the recording makes that easy. Now, going to a live in-person event, take notes and make sure you get some sort of book. I know a lot of, instructors have switched to digital handouts, and there's an argument for and against that. I do like having a paper book that I can put on a bookshelf and make some notes on, but at the same time, having a digital handout and a method of storing that somewhere where I can access it anytime, like maybe a Google Drive or the Files app on my phone, that is nice because no matter where I'm at, if I've set myself up, I can access that. I don't have to drive home to get a book or keep them with me in my van. I can just access it through my phone or a computer, and I can look up that handout and what was John talking about when he scoped the one thing on the one car? Oh, okay, there it is. Hey, that's my problem. Hey, this is the system I'm working on, and here's the information, right? But you got to go to training and think about when you're going to training, I'm going to try to absorb as much information of this as I can while I'm there, but what do I do a year later? This obscure case study that John has, maybe I don't see a car like this for 2 years. The odds of me, and specifically me, you might be better at this than I am, remembering the details on that and what were the voltage values on this red wire that goes to this anti-theft module. I'm not going to remember that. I've got to have a way to store that information. Okay. And when we're going to training, whether it be in person or online, think about, as you're going into it, how am I going to retain this information for future use? Okay, so I retained it. How am I going to access it for future use when I'm in that moment? And that might be as simple as a book that is in a drawer in your toolbox, and that might work perfectly for you. It could be digital access as well. And you can set yourself up with some sort of storage file. And, there's all kinds of cloud services that you can store digital material. And then all you need is a password, username, and you can access it wherever you're at. That's huge. And that's been huge for me because the volume of information that we have to absorb as technicians doing this job is enormous and ever growing. And I've just given up on trying to remember it all. So I focus on having a good system to reference this information when I need it. But the first step to all of that is you got to go get some training one way or another to prepare yourself better for when you're in that moment. Okay. Because had I not gone to training, I had not heard about that obscure case study. Well, now I've got to battle through it myself with no help because I didn't even know that John ever solved that problem. Okay. But I took the 2, 3, 4 hours out of my night to attend this class and gain that information. And again, on top of that, store that information somewhere for future use, but going is the first step there, right? So my big thing there is I'm encouraging you to go get some training, and especially on the stuff that you don't know very well. I mean, that should be the reason that you attend any training class. And people will say, okay, well, I'm always going to go to like a basic electrical because I can learn something there. And I agree with that, but really go for the things that are your weaknesses. Go for the things that you're not familiar with. I need to take more diesel classes. I really do. And I keep not doing it because there's something else I really enjoy network stuff better. I'm going to go to the network class. Well, okay, I suck at diesel stuff because I'm very inexperienced with it. And I keep running into shops calling me on like diesel emission stuff. Okay, I just got to sign up for some diesel classes. I got to take them. It's just a matter of identifying where your shortcomings are and then trying to seek out training that involves those. A couple more things here that you can do to set yourself up for success when you're in that moment you don't necessarily understand a system. This one does take some dedication and it does take some time, and you got to look at this as an investment. Otherwise, it definitely can seem, and maybe even in some cases can be, a waste of time. And this is testing known goods and documenting your results. Okay. And there's two parts to this, right? One of them kind of ties in with retaining the information from training, but testing known goods takes on, many shapes and forms depending on what we're talking about. But let's just say something like an air fuel ratio sensor on a Honda. Okay. Just something simple. And I want to know, how does this thing act when everything's good, everything's working fine? What are the voltage values? How does it react to a snap throttle? How does it react when I put propane in the intake? How does it react when I make a vacuum leak? Whatever. Okay. And then document those results. Okay. It's, 2.5 volts when I do this. It's 1.1 volt when I do that. All right. What happens when I unplug it? Does it set some circuit codes, right? We're testing the system to see how it reacts under normal conditions, and maybe we can introduce some faults too and document that. The problem with doing this is that it does take time. And I wouldn't say this is a problem, but the other part to this is you got to document this stuff too. Unless you got that brain and you can remember everything photographically, fantastic, more power to you. But I need to document this stuff when I do it. And so I use a Google Drive. I have it set up where I have a vehicle like a Chevy Silverado is the title for one of my Google Docs. And within that document, I break it down by year. And if I get a 2014 Chevy that I have some information on, I gain that from whatever, I'm testing a known good, I'll make a note there that, hey, the sensor voltage normal is this. Now, I'll be totally honest. I don't always sit around and just test known goods. I don't have the time for that. And so I'm telling you to do it, but I'm also saying, well, I don't really do that. Here's how I do it. When I fix something, okay, when I actually get to see the repair, which isn't always doing the mobile thing. I don't always get to see the fix. But when I fix something, I will document what is good and also what is bad. And that can be very valuable information as well. So I say test known goods, but maybe I should say test known goods in comparison to the known bad and get both values, or get both ways that the system reacts, right? What are the symptoms, and what are the test results when there's this problem, and what is it when it's good, right? That's your chance to make this less time consuming, because all you're doing is you're verifying your repair, right? You put that sensor in, it fixed the problem, right? Code's gone, check engine lights off. Okay, well, what are the values now? And what were they before? And have those documented down for yourself for future use, right? Now you're setting yourself up for when you run into this in the future. And you might say, well, it's not really an unfamiliar system. Fair enough, but maybe you don't see this same problem or the same car for a year or 2 years. And if you're in the independent world, that is totally possible. And maybe you're working on 10, 15 cars a day. Okay, it's going to be tough to remember all of the details. So part of this is, actually doing it and comparing it to known bad, but the other part is documentation to save it for future use. And again, that goes into the training thing that I mentioned. So I'm bringing it up twice. It is an important part that I think everybody should be doing. Some type of, you might call it journaling or documentation for your own reference. And that's huge. It's been so huge for me, and it's ever growing, right? I do it at the end of every day. And it's tough because some days you're busy. Some days you don't want to. Some days maybe you don't feel like you have that much of important information. It was a pretty standard day. All this stuff was repetitive. Well, try to think of something that was new that you hadn't seen before, that was different, and just jot it down, reference it to yourself, and find a way to store it. You can do this on paper. You don't have to do the Google Docs thing. I like the Google Docs because I can access it anywhere, right? And I use this a lot for programming, for key stuff too, like all the processes that I've got to do, and it is really helpful to reference that in the future. Now, the last part of this, and I've actually used this documentation here too, is networking. Okay. This is one of the tools that you can actually use in the moment. Now, you got to set yourself up for it ahead of time. But when you get in a pinch and you have no idea how this system works and you're really not sure where to go, maybe you're at the limit of your capabilities or your understanding of the system, you can't find any service information, whatever it might be, you're kind of stuck. Okay. Having a network of people that you can reach out to is so important. It might be, besides having service information, it might be the most important on this list, or the most powerful on this list of things that you can do to help yourself understand how the system works. Because if you can have another person who has already been through this explain to you, oh yeah, this is how it works. This is usually what they do when they're bad. Here's the voltages that you're looking for. This is how it reacts when there's this problem introduced. Not just necessarily, oh yeah, I fixed that with this, but this is what happens. Here's what you want to test for. Oh, that test result means this. Having some people that can help you out with that is one of the most powerful things that we can do as diagnostic or programming technicians, or just technicians in general. It is so powerful. And if you're not doing it, I would so recommend finding a network of people. Now, this can take different forms, right? We've had things like IATN for a really long time, and that was a classic example of utilizing the internet and bringing technicians together. We have Facebook groups. That's been around for a number of years now and very popular, and there's endless groups of Facebook, where technicians will get together, and varying levels of do I really want to be in this group, and is it really bringing any benefit? And some of them are just shit slinging groups. They're not all great, right? But there are some really, really good ones out there that I would encourage you to seek out. And there's some great information, and they're searchable. That's the other thing. Use the search function, not only within, a forum or a Facebook group, but you can even use this in chat groups. And this is one of the points one of the things I want to encourage everyone to try to set up, if you're not already, is to create or get into some chat groups with some like-minded technicians. Okay. I'm in a number of them, and they are incredibly powerful and valuable to my day-to-day operations. The amount of information that you can get at your fingertips on a extremely short notice, there's nothing else like it. You could draw some parallels to the chat groups and the Facebook groups. I would say the main difference is if you're putting up a question in a Facebook group, you're putting up that question in front of 1,000, 2,000, 10,000 eyes, right? And while that could be a good thing because you're pulling from a larger group of knowledge, depending on who you are, you might have some hesitancy to put a question up there that maybe you feel like you should already know. Or maybe you don't feel that up front, but there's some asshole in the group that needs to feed their own ego and berates you because you're an idiot, because how could you ask a question so stupid? You weren't born with this knowledge, right? We've all seen that person in Facebook groups, and it stops people from asking questions they legitimately don't know the answer to. Okay. Now, yeah, okay, you can do your legwork beforehand before asking a very simple question. I understand that. But where I'm going with this is presenting the same question within a small group of trusted individuals, maybe 5-10 people. You're going to feel a lot more comfortable doing that. And so will the other people, right? And so maybe a smaller knowledge base, but I would say it's more intimate, and you can share information back and forth very quickly without worrying so much about what everybody thinks about the answers. I mean, maybe all of you are wrong with the information that you're trading back and forth in a small 10-person chat, but you start bouncing ideas off of each other. You're communicating, you're open about what you're thinking about this and not really trying to impress anyone. You're just sharing information, trying to grow, trying to figure this out, and you get to the solution that way, rather than an ego contest in a Facebook group. And I'm not trying to say anything against the Facebook groups. They're fantastic, and they changed my career. 100%, they changed my career. But when I'm in the middle of a problem lately, I think those chat groups are extremely powerful for getting to a solution quickly without dealing with so much of the, extra stuff that you find in the larger groups. I'm sure people look at that differently than I do, but I would recommend finding some people, and this is a great thing to do at a training event, is get to know some people. You don't have to be best friends with somebody. I mean, shoot, you want to be in a group with me, shoot me a message. We'll get some people together. Find some people and just start a dialogue. It doesn't have to be the smartest person in the industry, but you might be surprised at the amount of knowledge that people have once you get to know them. Or, I've always thought about it this way too, is everybody has something that they're really good at. And some people aren't that vocal about it, but once you get to know them, you're like, wow, this dude knows this, fill in the blank, so well. I'm so impressed. And I had no idea that they were so well versed in this one topic until you get to know them a little bit better. And that's another thing with the chat groups, is you really do get to know your fellow automotive technicians. So I would highly encourage that you do that. And also when you're in there, I don't want to forget this, make sure that you're contributing too. And that goes for the groups, that goes for the big Facebook groups, the chat groups, whatever it is. Make sure that you are offering something. You're not just a leech of information, right? And because that can definitely happen too. Now, of course, you might be new. Your ability to contribute might be less than someone who has 20 years of experience. I understand that, but don't specifically be there. Don't only hop on when you're trying to get information. Try to help people when you're able, or at least offer ideas, suggestions, contribute in some form, so that when you need something, it's a fair exchange, or closer to a fair exchange. But that's going to wrap it up for me today. That is what you can do ahead of time and in the moment to help you work through something that you don't understand. But first and foremost, try to ask yourself honestly, do I understand how this thing works? And if you don't, well, you're not going to be able to play the game very well. I'd like to thank everybody for listening to the show, all the feedback I've been getting. Thank you. I know I don't get back to everybody right away, but I do try to get back to everybody, so I appreciate it. If you want to be on the show at some point, hit me up, email or Facebook. It's in the show notes. I am down to talk to anybody who's passionate in the auto industry about whatever topic you got. But with that out of the way, let's all get out there, start fixing the world one car at a time.